Hey, my name's Avery, and in this video we're going to be looking at a problem with area with different variables and how you can solve it with calculus. So I didn't feel like writing this whole problem out, so I'm just going to read it off of the screen, but the question says, a farmer has 1,800 feet of fencing to create a rectangular pasture, for his goats and cows. He's going to use a river as one side of his pasture and plans on using the fencing to divide the goats from the cows. What is the maximum amount of pasture that he can make for the animals? So I kind of redrew the diagram right here. This is representing the river. And then I started out just writing the regular area formula, length times width. And then, like in the video Mr. Moore posted, we want to assign each of our lengths that we're trying to account for with a variable. And since we know these three are going to be the same, that it's going to be the same variable. So I just used x, and one of these x's is going to be our length, which I wrote right here. And then in order to find your width, you would just take your overall amount of fencing available, which is 1,800 feet, and subtract 3x, since we've got three of these different lines of fencing that we know we're going to need. So I just substituted both of those values into the area formula, which gives you x times 1,800 minus 3x. Distribute the x, 1,800x minus 3x squared, and then you're going to want to find the derivative of this. So in this case, a prime is equal to 1,800 minus 6x, and then you're going to want to set it equal to 0, because in this case we're trying to find a max. We're trying to find the max area possible with the given amount of fencing. And when you're trying to find a max or min, you know that the slope is going to equal 0 at that point, which is why we want our derivative to equal 0. So this is just algebra, subtract 1,800 equals negative 6x, divide, and then you get 300 as your x, which, as we know, is our length. And then we're going to move over here to find the width. Since we know what this x equals now, we can just plug it in to our formula we'd made earlier. So you have 1,800 minus 3 times 300, which gives you 1,800 minus 900. And then finally, your width equals 900 feet. And so you're going to take your x, which is your length, and then take your w, which is 900, plug it back into that original area formula. 300 times 900 gives you 270,000 square feet, which is what we were trying to find, the maximum area, basically, of the fencing that's available. And then one last thing, this is just optional to help check your work. I graphed our original equation we'd made over here with the area, our 1,800x minus 3x squared, which is a parabola, and then I graphed the derivative. But if you come up here and you find the max of this parabola, you will see your x equals 300, and then your y, in this case, equals that 270,000. And so that's just another way to double check your work. You can look at the max right there.